Good evening, everyone, and thank you for attending AACP's webinar with Dr. Azita Shahgaldi, presenting Introduction to 3D Printing. I'm Shaylin, the Association Manager for the AACP, and I will be the host of the webinar tonight. The webinar is approximately 50 minutes, followed by a 10-minute Q&A session. Please enter any questions you have in the Q&A box at the bottom of your Zoom screen, and we will address them at the end of the presentation. The AACP has no conflicts of interest. Registrants can expect to receive a recording of this presentation via email within 10 to 14 business days, and AACP members attending live will receive their CE certificate of attendance within 30 business days. AACP's next complimentary webinar will be on January 8th with Dr. Nathan Jurgensen presenting Creating a Speaker PowerPoint that Resonates. Also, join us for Evaluating the Occlusion Box, a hands-on view of the complex triad of joints, muscles, and teeth on January 31st through February 1st in Scottsdale, Arizona. You can visit aacfp.org to register. I would like to introduce our speaker for tonight, Dr. Azita Shahgaldi. Dr. Shahgaldi has lived in Southwest Portland for over 20 years and went to Portland State University and received her bachelor's degree in general science. After graduating from PSU, she went to dental school at Oregon Health Sciences University, where she received her Doctor of Dental Medicine in 2010. Dr. Shahgaldi is dedicated to lifelong education and spends a significant amount of time taking continuing dental education courses in advanced dental technology. She believes strongly in blending modern technology, art, and evidence-based dentistry to provide the highest quality care to her patients. She is a true artist who enjoys painting, photography, crocheting, and knitting. She's also passionate about volunteering her time to provide dental care to those in need with different organizations locally and internationally. And with that, it is my pleasure to hand it over to Dr. Shahgaldi.
Good evening, everyone. I'm glad everyone's here, and I know you guys are excited to learn about 3D printing, so let's get started. Tonight, I want to talk about 3D printers that are currently on the market, materials that are available for 3D printing, and also scan to print workflow in a dental or medical office. The three printer types that we are going to talk about tonight are FDM, or Fuse Deposition Modeling, SLS, Selective Laser Sintering, and SLA, or Stereolithography. When you talk to your neighbors and friends about 3D printing, they most likely talk about FDM because that's a common desktop 3D printer that a lot of families now have and print a lot of toys and gadgets on. And if you can think of a hot glue gun where you insert the glue stick and then it has a heating element where it heats up the glue and then extrudes liquid glue. FDMs are very similar to that. They have a heating element, a nozzle that heats up the filament, and there's a spool of thermoplastic filament that goes through, and then it melts the filament and it builds layers at a time. FDMs are great for printing large objects, toys, gadget, figurines, and whatnot, but they really do not have a place in the medical and dental practices, except for printing models for patient education, because these printers are not very accurate, and the layers that they built currently, the nozzles can do like 0.2 to 0.4 millimeter layers. And for a toy, that's pretty accurate. But when it comes to dental devices. We just don't have much of a use for FDMs in our offices. As you can see, here's a close-up of the nozzle where the filament is extruded, and then as it extrudes, also it cools down so that it can build an object layers at a time. If you take a close look at a 3D printed object on an FDM printer, you can see the layers. The picture on the right is a toy a friend of ours has printed. It's kind of a spinner that our family really enjoys playing with. It has a different part as well that this kind of spins through that. But when you look at it, you can see where the filament colors change. But again, these are very popular for printing stuff at home. And we do enjoy printing on these as well, but not for my practice. I have a video of how FDMs work if you guys are interested in seeing how these printers melt the filament and extrude the filament. And also, these can be a single nozzle or double nozzle if you want to have two different color filaments printing at the same time within the same print job. So here the build plate is moving and the nozzle's moving and it's printing uh, these objects. Here's a double nozzle FDM and you can see the spool where it's feeding the nozzle basically. For FDM printers, there are so many different types of filaments. I have listed a few of them here: nylon, PLA, ABS, color changing filaments like the little spinner toy we have for our family. But the list is really long. You can really print a lot of different materials on these FDM printers. If you are interested in getting an FDM printer for your family to print fun stuff, there are a lot of free SDL files, and SDL is the file format for 3D printing objects. Thingiverse and Thangs.com. These are the two websites. I have found a lot of great free STL files. I'll give you guys a minute here if you guys want to jot this down. Right before the holidays now, if you guys go to these websites and just maybe type in a Christmas tree or I don't know, an elf, whatever it may be, you'll find hundreds of free STL files to download. And also, if you are into, figurines or any kind of Disney characters, if your children like that, there are a ton of free files for you to download and print on an FDM printer. The next type of printer I'm going to talk about tonight is SLS, selective laser sintering printers. Instead of having a filament, these actually work with powder. They have reservoirs where you fill your material, and then the laser melts one layer at a time. And many materials can be printed with SLS printers, including metal. They're highly accurate, and many industries nowadays use SLS printers. Anything that in the past we would cast can be printed on an SLS printer. So, for instance, gold crowns. A lot of your labs, if you're still using gold, most likely are not casting those gold crowns. They are printing those gold crowns on SLS printers. In the medical industry, a lot of custom joint parts, also airplane parts in the automotive industry, and also jewelry. A lot of large jewelry manufacturers are no longer casting jewelry, they are printing them on SLS printers. I have a few examples here in dentistry. You can design a customized MARPI and print that marquee on on an SLS printer, and a lot of prosthetic body parts, joint parts are nowadays printed on SLS printers. Here I have a comparison for you guys of what printing the same file on an SLS printer versus an FDM printer looks like. And as you guys can see, SLS is a lot more accurate than FDM. And if it's a part that you're going to use on, in a human body, you definitely want it to be very accurate. The third type of printer we're going to talk about tonight is SLA, stereolithography printers. And these printers are also are highly accurate, high resolution. And instead of having a build platform like an FDM, they have a build plate that's actually on the top. And then they have a resin tank. The bottom of that tank has a clear material. And then down below, the machine either has a projector, a laser, or a LCD. And then the layers are cured on the bottom of that resin tank. And I do have some videos that I'll show you guys in a few minutes here. There are three types of SLA printers. The first one I'm going to talk about is laser, where you can see in the image on the right side, you have your build plate, you have your resin tank, and down below, you have laser. If you can think of a laser point, and if you are trying to basically draw something with a laser point, you're going to draw it and then you're going to fill it in. So if you are printing a large object or you're printing multiple things on your build plate, it's going to take a long time because it is going to draw every single object, every single layer. So if you have a full build plate that you're gonna a print plate that you're gonna print, it's gonna take about an hour for per third of an inch. So if you have a high, a tall object, it's gonna take many hours to print on these laser type SLA printers. The next type is a DLP printer, where it actually projects a layer at a time. So on this picture, you can see a pyramid, but if you had 10 pyramids printing next to each other, it would take the same amount of time because it is going to project a single layer for all those 10 pyramids at the same time, print a layer and then move on to the next layer. These can print about 2 inches per hour. And then the third type is an MSLA. It's a masked stereolithography printer where the light source always remains the same. And then the light source goes through a masking layer. And the only light that hits the bottom of the resin tank is the shape of the object you are printing. So again, with these, the same as the DLP, the build time depends only on the height because it doesn't matter, the area that you're printing. It's going to print one layer at a time. I am going to show you guys a video of an MSLA printer. This is a Formlab printer, and this video is on their website. Let's take a look. So with this MSLA, you guys are going to see the light source on the bottom. The entire thing comes on. It goes through different layers. There is a masking layer that masks everything else except the shape of the layer that's being printed. Again, layer at a time, the build plate moves up, cures another layer. till the entire object is printed. After the print job is finished on SLA printers, you have to process the objects because they are going to come out covered in liquid resin that has not been has not been cured, sorry. As we just saw on the video, every time it cures a layer, the entire thing, kind of is in the resin tank. And as it cures the layers and it comes up, your object is going to be covered in liquid uncured resin. So that has to be washed with alcohol, and then you have to cure because even though it's curing, it is not 100% cured. And the curing time is going to depend on the material you're printing. And then if it's an appliance that you're going to deliver, it has to be polished. So in my practice, we don't polish models because they come out not needing any polishing. We don't polish surgical guides. The only thing we polish are crowns and splints and night guards. We don't do dentures, but if you printed dentures, they would need post-print polishing. Applications of 3D printing. I've been 3D printing for many years, and the applications keep growing. But currently, you can print splints, night guards, surgical guides, dentures, temporary crowns, and also semi-permanent crowns currently, because we have resin now that has ceramic particles in it. And those crowns are considered semi-permanent. But I do believe in the next few years, with the development of new resin, we may get to a point where we can print permanent resins as well. Hybrid dentures, models, retainers, sport guards, and bleach trays. When I first started printing, we would print the model and then we would do a suck down on our mini star to make retainers. But now we can print retainers directly, and there is no need to print the model and do a suck down. And when it comes to resin selection, there are many brands out there that have great quality resin. And also, there are some European resin companies that are entering the US market. And some of them are waiting for FDA clearance currently. And a couple that I know uh, they are expecting to have their FDA clearance in quarter 1 of 2025. So in the next few years, we should see a lot more resin companies and a lot more options out there. But currently, these are some of the top dental resin companies that we use. Um, Keystone is the one we use for all of our splints. They have a hard and a soft splint resin. And when I say soft, it's really not soft, but it's not as hard as their hard resin. We use Sprint Ray resin for our temp crowns. We use Applied Labs for our models. But each of these brands, the selection is really good. And once you start printing, you're going to have your favorites. So when I talk to other doctors who print, their favorite resin for certain applications is different than mine. So you're just going to have to try out different brands and see what you like. Um, I am going to spend the rest of the presentation time to go over scan to print workflow and how we print appliances in our office. So I'm going to go over 7 steps or that is required in a dental office from scanning to polishing. So the first thing we need to do, obviously, is do an upper arch, a lower arch scan, and a bite. And depending on what it is that you want to design, you're going to take a different bite. So we can do a phonetic bite, a decompression bite, neuromuscular. If we're doing a crown, we're gonna take the bite in maximum inner cuspation. So whatever it is that you currently do and send it to the lab, it's not gonna change. You're just gonna take your bite for your appliance. And then you are going to design your appliance. And when it comes to designing, we have different options. You can design in-house. And if you get really good at some of these design software, you can design a dental splint in like less than 5, 6 minutes. Surgical guides take me about 10 minutes to design. Crowns are a lot quicker because a lot of the workflow is done with AI. You no longer have to like trace everything and design everything. AI does a really good job of doing that. There are also cloud design services where you can upload your scan into the cloud, and then they have technicians where they would design and send you the STL file, and then you can just, use that STL file and print your device yourself. If you have a great working relationship with a local lab and you don't want to get into designing appliances in your office yet, you can definitely have your lab design the appliance and just send you the STL file, and then you can print it in office. And as of this year, we have been using AI design services, which has been really nice for things that don't need a lot of design work, and it doesn't need a lot of like bite. Setting the bite correctly, like a splint, we use AI. For retainers, for instance, you can just upload your scan, and within 2 minutes, AI is going to give you an STL file that's ready to be printed if you have a printer that's compatible with retainer printing. And after it comes out of the printer, the post processing is really easy. Usually, retainers don't need much polishing. All you have to do is wash it and cure it, maybe buff it a little bit where it had a few attachments, and it's ready to be delivered. I have listed some of the popular or commonly used 3D design software here. Some of these are free software and some of them are paid. I use Blue Sky Bio for all my surgical guides. Blue Sky is a free software that you can upload your um, CBCT and your 3D scan. You can design your surgical guide. And then when you go to export it to print it, you pay $25 per export. MeditLink is another great design software. It is free. You don't have to own a Medit scanner to use MeditLink. You can bring in scans from other scanners into Medit and design. They have a great frown module, they have a splint module, they do have a wax up module. And once you design in Medit, then you export your file and you can print it on, any SLA type printer. D3 tool I like for splints, especially for, TMJ splints where you can really set the bite exactly how you like it, take your appliance into excursive movements and then print it. And once it's printed, usually it doesn't need much adjustment. The bite is ready to go. InLab is a Sirona product. So if you are a Sirona doctor and you want to get into 3D printing, InLab is probably going to be your go-to. BD4 is another software that a lot of dentists use. I personally have not used B4D, but I know a lot of colleagues who do use B4D. Exocat, if you're really going to get into 3D printing and you think you're going to print everything from dentures to surgical guides to crowns to splints, Exocat might be something you want to consider. It is somewhat expensive software. If you want to buy the entire library, I believe it's about $10,000. And then you have to pay about a $1,800 um, annual fee to use ExoCAD. 3Shape Studio, if you have a 3Shape scanner, you can use 3Shape Studio for a lot of your design work. Mesh Mixer is a free software, and I don't use Mesh Mixer for designing any appliances, but I do use it for joining different files. So if what I'm printing has multiple parts and those parts are designed individually, I will bring them into Mesh Mixer and then join them so that I can print a single file. And currently, to give you guys an example, if we do a sleep apnea trial appliance where we just want to print something in-house for the patient to try and see if it improves their sleep apnea, and then we can move them to a medical device. We just print it, and in Mesh Mixer, we can use we can bring the button STL files and we can bring the appliance that we print and then join the buttons and the appliance and then send it to the printer. Um, the next step, once you have scanned and designed your appliance and you have your file to be printed, you have to slice your file because that file is going to be an STL file. That's a 3D object file, but our printers print layers. So they only understand layers. So now we have to take our STL file and we have to slice it so that we can now communicate with our printer what we want to be printed in layers instead of an entire object. Some of the slicing software we currently have, there are a lot more, but Chi2Box is a good one. It is a free software. Cura is usually used for FDM type printers, but also Rayware, if you use Sprint Rayware will do the slicing for you. There are many more slicing software out there. Some are paid, some are free. But if you're getting started, Chi2Box is a really great free slicing software. Once you have sliced your STL file, now it's ready to be sent to your printer. So you're going to send that to your printer, and your printer is going to start printing that one layer at a time. And depending on how tall it is and which type of printer you use, it can take a few hours if you have a fast printer, one of the newer ones. Dental splints can be printed in 45 minutes on some of the newer printers. After the print job is done, you have to wash your print and then you have to dry it. When I started printing, there were no wash machines. We were washing everything by hand. So we had Tupperware full of alcohol, and we would cut the tops to fit the shape of our build plate, and then we would insert that and we would submerge our object. And then I had magnetic spinners that we would put at the bottom so that they would spin and kind of agitate things around a little bit. And then we would take them off the plate, and then we would submerge them again in the alcohol, and we would use denture brushes with our hands, gloves submerged, in alcohol, and then we would take them out, lay them on towels to dry, and then we would cure them. But as of 2020, we have a wash machine where once our prints are done, the build plate goes directly into the wash, and we just hit a button and walk away, and it washes and dries the print for us. And then once they're washed and dried, now they have to be cured. The cure time depends on the type of resin and the type of cure machine you have. This is actually the model I currently have and I've had for since 2020. It can take up to 30, 40 minutes to cure things, but the newer models can be as fast as like 3 to 5 minutes. And depending on your appliance, post-curing, you are going to polish. The first thing we do post cure, we clip off the support structures, and then we use these Scotch wheels to buff out where the attachments were. And then depending on what it is, then the polishing process is going to be different. If it's an appliance, if it's a splint, then we do the pumice and other polishing wheels to get them really nice and shiny and smooth. If it's something like a surgical guide, again, we just clip the supports off and we use the Scotch wheels just to buff out the sharp edges and points, but we don't do much polishing because we're just going to use them for like 10 to 20 minutes and then throw them away. So there's no need for high shine polish on those. When it comes to selecting a 3D printer, you have to first think about the application. What is it that you want to print? Do you want to print metal? Do you want to just print models? Or do you just want to print some toys? So your printer selection is going to depend on what it is that you want to print on daily basis. How accurate does it need to be? As I said earlier, FDM printers are not very accurate, but very fun for families to use. Also, the volume of print. The image I have here, it's actually a colleague of mine who does a lot of ortho, and he does a lot of in-house aligners. So I think I counted this. There are 43 vertical models on this build plate. And usually what he does is his printer is not very fast, but he would print overnight. It could take 8 to 10 hours for something like this on a slower printer to print. But as long as it doesn't have to be a same day and you guys can load on a large plate and run it overnight, then possibly you don't need an expensive fast printer. But if you want a same day chair side crown, you're going to need something that can print, in a matter of, 20, 30 minutes. I want to now go over our workflow, our 3D printing in our office. This is our 3D printing lab in the back of our office. On the right side, we have our printer and our wash. We have two cure boxes. And on the left, we have our polishing equipment. Again, here, our printer, our wash machine next to it, and then we have our cure boxes on top. Our equipment is in today's with today's technology considered a little old. It's time for us to upgrade because we've had this printer for about 4 to 5 years now. And then on this side is all of our polishing machinery, all of our polishing tools. Um, Something I want you guys to see is we have a whiteboard on the wall, and it has doc and team. There are certain things in our office that my team can design and print without me at all being involved with it, and certain things I design myself. So if they scan a patient and we need to print something, it goes on this whiteboard and with the date that it's due. And then, we'll work on the list. We've tried different software. We've tried like Teams, and we've tried Asana to have an ongoing list of what needs to be printed. And then last year we decided, you know what, we're just going to go old school. We're going to have a whiteboard. If Doc needs to design something, put it on her list. If the team is going to design something, put it on their list. And then you can see our laptop here. This is a laptop we use to design things. I have all my software for designing on that laptop. So when you design an appliance, and I just have a simple, occlusal guard here to show you guys. And once, no matter what software you use, you're going to have a 3D object of your appliance that now you are going to send to your slicer software to slice and have ready to print. So this is my slicer. We use Rayware to slice our objects and or our STL files. And I'm gonna show you guys a quick video of this was actually earlier this week. I think this was like Monday morning. We were printing some stuff for patients. So that is my the size of my build plate basically. And I'm gonna bring in my files. We have a folder called ready to print. If I design something, if my team designs, we just put it in that folder. And I'm gonna bring my files in. Dental splints are best printed at 45-degree angle with supports because if you don't add supports, they can warp. So now I'm gonna go in and I'm gonna flip them around and set them at 45-degree angle, get them ready. And then I'm gonna add my support so that as we print, because as you guys remember, the resin is not 100% cured. It has to be cured post-print. I added my supports there and they are ready to go. Sometimes if I mean on this platform we can fit up to 6 splints. I'm gonna now pick my resin and I'm gonna print these on Keystone Soft. I'm gonna apply and I'm gonna print these at 100 microns per layer. And here I'm confirming 100 microns, correct material. It tells me I need 12 mils of the resin for these two appliances. And then it also tells me how long it's going to take to print, 3 hours and 19 minutes. And now my slicer is going to go through on the bottom. You guys can see it's slicing these. And I believe these were about 270 slices that the slicer now is going to send the data to my printer. And I'm going to show you guys a video of our printer. So first, actually, I'm going to show you guys this image here. When I design or my team designs something, depending on what was printed previously, we have to check, make sure we have a clean build plate placed and we have the correct resin tank in with the correct amount of resin. Because if we are printing, let's say 20 vertical models, and we need 400 milliliters of resin. If there isn't enough resin, it is just going to fail and you have to start all over. And it's such a big waste of resin and time. And we have done that before where we have started prints and the assistants have been checked to see if the volume of resin that's in the tank is adequate for the volume of print we're sending. And then it stops printing, midway, and then we have to toss everything, refill resin, and start over. So always make sure that you have the correct amount of resin in your tank for the print job. Down below from our printer, we have all of our tanks labeled with the resin types we currently use in our office. And we also have backup bottles ready to go as it runs low. We just refill those tanks. And once in a while, when a print job fails, your model, instead of being on the build plate, it'll actually stick to the bottom of your resin tank. And you have to drain the tank and peel that off gently and not damage the tank. But sometimes the tanks do get damaged and scratched and they have to be replaced. But in general, these tanks are good for 15 bottles of resin. And after you have printed 15 bottles of resin in them, they do need to be replaced, which, we usually have a couple backups as they go bad. We just drain the resin and put them in a new tank and then, relabel the tank. Um, Here's a quick video of once we have sent our print job to the printer, what we do next. We typically don't hit print right away because what I have learned over time is, you know, if if your staff even tells you or tell each other that it's ready to go and you hit print and it goes to the printer, sometimes the wrong resin tank is in. So I always just cue the prints and I make sure whoever is printing double checks to make sure the right tank is in and a clean build plate is also ready to go. So this is me Monday morning printing what I just showed you guys that I just sliced the two appliances. Here's one of our build plates. Make sure it's clean. And I lock that in, make sure it does not move. And then I'm going to come down to the screen and I'm going to go to Q. And then I'm going to pick the print job I want to print next. I'm going to confirm 12 mil and the right resin, and I start the print. As I said before, we've been using this printer for many years. There's a lot of layers of cured resin all over it. So when I look at this video, like, yes, it's time for us to upgrade. So the next video I want to show you guys is about an hour, hour and a half maybe in, and I want to show you guys how a DLP printer cures every layer. I am gonna basically show you guys the screen first, show you guys the layer. That's the layer it's printing currently. So you guys can see there, the DLP is shining the light for the layer that's being cured on the bottom of that tank. There, you guys can see that blue line going, that layer is being printed. That's done. It comes up so resin can go kind of cover the bottom again, and then it prints the next layer. It stays there depending on the type of resin. The time that each layer takes is different. So with our soft keystone, each layer, I want to say it takes about maybe 30 to 40 seconds, but with other resin, it's different. Now the print job is complete. You guys can see kind of we still have more print to go in the queue. But once it's done, those are the two we just sent to the printer earlier that day. They're printed, they're done. We're gonna take the build plate and it's gonna go straight into our wash. The wash machine is very similar to a dishwasher. I want to say it just sprays high pressurized alcohol. It has two chambers. It has a first wash and a second wash. The first wash alcohol usually is, for a lack of better term, it's dirty. And then the second wash alcohol is clean. And then once your first wash gets really dirty and it has a lot of resin in it, the machine will tell you it's time to replace that. So then what we do is we drain. You guys can see those little ports. There's a hose that we connect there. And in an earlier photo, if you guys paid attention, there was a wrench in next to the resin tank. So we connect that. We drain that into a bottle, and then it puts the clean cycle alcohol into the first reservoir, and then we pour clean alcohol into the second reservoir, and then we just basically cycle it like that. And then once they are done, they are washed and dried. We take them off of the build plate, and then they go into the cure machine. And I couldn't do a video because it's really, really hard to do a video when you have all these curing, strips going. The video didn't turn out that great. Um, Selecting a 3D printer. If you guys, after this presentation, are excited to own a 3D printer, um, these are SLA type printers, Formlabs, DentaFab, Frozen, Shining, Sprintray, Sega. These are all great brands. Depending on, again, what you want to print, how fast you want to print, the volume you want to print, and the kind of resin you want to use, you just need to you need to do your homework and see which printer fits best for your practice. And that is it.
Wonderful. Okay, thank you. We do have a few questions for you. One is, do you have any experience or knowledge to compare Lux Creo printers with Sprintray?
I do not. I currently use Sprintray, but I would say I would meet with both reps and get the specs and everything. But there is a great there are some dental printing forums and groups online. Maybe try that and post your question and see if somebody has used both of them.
Perfect. What would you say the learning curve on the use of this, provided that the DA/DR are comfortable with handling digital files? And any preference on the digital scanner?
Um, I would say you have to pick the DA in your practice that's most tech savvy. We've trained over the years multiple assistants on it. And the ones that do well, you kind of know right off the bat, they're excited about it. They comprehend it. They understand what they need to do. And the biggest issue we've had is not on the design side, but it's on the print side of things where they get busy and they, as I said earlier, like they won't have the right amount of resin, or they'll have the incorrect resin tank, or they won't have the build plate on, and or they will. I've had one assistant actually put too much resin, and as the build plate went in, the resin actually got into other parts of the machine. But I would say maybe initially, if nobody in your office knows how to design and you guys just want to start printing, have someone else do the design for you and send you the STL file. And once you guys get comfortable printing the file, then move on to training someone on designing the appliances in-house.
Great, thank you. Do you have a fume hood or some type of ventilation?
No, it's not necessary. There usually isn't a fume. Once you walk into the lab, obviously it's a resin lab. You can smell resin, but that is not necessary. Once every print job is done, we put the lid on the tank and put it down below. Um, and our lab does have a window if we ever need to open it. But to be honest, we don't open our lab window much.
Okay. And what angle and how many supports are needed, for example, an arch or retainer?
A retainer, just like a splint, uh, it's best to print it at 45-degree angles. When you go to add your supports, you can select the density of the support. I like adding a lot of support just to make sure it doesn't warp, because the last thing you want to do is take it to the patient chair side and it doesn't fit. My recommendation would be initially if you're printing appliances and if you're printing print retainers, just to get a feel for the fit. Go ahead and print the models as well, obviously in a different type of resin, and try that on the model to make sure what you're printing and how you're designing and the number of supports you're adding is sufficient. And once you've had half a dozen of those that fit and snap right onto the model, and you know your workflow is working for you, then you no longer need to print the model.
Okay. And what is your go-to resin for retainers?
Sprinray has a retainer resin that works really well. There are other companies that retainer resin is kind of a newer resin on the market because, as I said, we were all printing models and doing the suck down. So I think within the next 6 months or so, there are going to be a lot more a lot more retainer resin that's going to come on the market.
Is there a resin as hard as PMMA?
Similar, yes. Sprinray, tough on X is a really good one, but other brands also have excellent tough resin for all on four. I'm assuming this question is for all on four temp, if they
Um,
can clarify.
yes, at the moment I am not sure, but we can ask for them to clarify.
Yes, there are really tough resin that you can print that is similar, but I'm not sure if it'll be as hard as PMMA.
Okay, and if any mistakes were made, oh, sorry, let's 1 second. They said for splints or orthotics, I need the hardness.
Yes, key splint hard. Key splint hard would be is our go-to when we need a really hard material for our appliances, for our splints.
And I think the last question is if any mistakes were made, how tolerant are the printing machines? Like you mentioned the spilling of too much material.
So if it spills and gets into the projector and gets onto the curing element of the machine, it has to come apart. You have to take it apart, and it actually has to go back to the manufacturer for service. If it spills around the tank, but it doesn't get into the curing part of the machine, you can just wipe it off. And sometimes when you put the tank on, if there's anything on the outside, it can kind of drip a little bit. As you saw in my video, my printer kind of has some resin around it. Um, as long as it doesn't get on your curing element, you can wipe it off.
Okay. Wonderful. Well, thank you very much for taking the time to present tonight. We appreciate all the information. And as a reminder, we'll send the recording within 10 to 14 business days. If you have any other questions you think of, you can email me and I can get those to Dr. Shahgaldi.
Thank you so much, everyone.
Thank you. Have a good night.